Hello everyone, welcome to another episode of Maths Phobia. Alright, now we started a series on bearing and distance. So let's quickly jump into this question of bearing and distance. Alright, follow me. X is a point due east of point Y. So point Y is the reference point. So we have point Y. This is point Y, north, south, west, and east. And we're told that X is due east. Due east. S is facing the east direction of Y. So this is X. Okay? So for X, the four cardinal notation. So X is due east of Y. And we also told that Z is another point on the coast, but 6.3 kilometers due south of Y. Y is our reference point. Don't forget that. And Z is due south. This is the south of Y. So Z is facing the south of Y. So this is Z facing the south of Y. We have a north, south, west, and then east. Okay, so what do we have? We form a triangle, alright? And this will also give us a right angle triangle. Okay, now Z is 6.3 kilometers. So Z is 6.3 kilometers from Y. So this is 6.3. Okay, and then if the distance XZ is 12, XZ is 12. Okay, 12 kilometers. Then we are asked to find the bearing of X from Z. From Z. Sorry, the bearing of Z from X. Take note. From X. That means X is our reference point now. From X. So the bearing of Z from X is the angle drawn from the northern direction of X. This is without the word, it is preceded by the word from. So the bearing of Z from X is the angle drawn from the northern direction of X, clockwise to touch the line connecting Z and X. So we know that this side is 90 degrees, and we have another 90 degrees to get the bearing. Let's call this point X. We need to get this side, then we'll add it to 90 and 90. But to get this side, we need to get this side. Let's call it theta. So this triangle, if I'm to turn it the other way around, I'm going to have something like this. Okay? My Z is here, my Y is here, and then my X is here, and this is my theta. Okay, so ZY is 6.3 kilometers, and then XZ is 12 kilometers. So if I'm to use my SOHCAHTOA, I'm not looking for distance. If I was looking for distance, I would have used Pythagoras theorem, but I'm looking for theta angle, so I'm going to use my SOHCAHTOA. Okay, so using my SOHCAHTOA, follow me. I have, this is hypotenuse, and I have opposite. So opposite and hypotenuse, what that shows we have sine, opposite and hypotenuse. So therefore, sine theta is opposite over hypotenuse, meaning my sine theta should give us, my opposite is 6√3, and my hypotenuse is 12. Okay, 6 can go here 1, 6 can go here 2. We can't touch these 3 because it's in the sub form, the square root form. So our answer is sub 3 over 2, meaning my theta, if I divide both sides by sine, I'm going to have sine inverse of √3 over 2. And if you use your tables or use a calculator, you see that our answer should be 60 degrees. Because sine 60 degrees will give us 3 over 2, or in decimal form, 0.8660. So I'm plotting my theta to the 60 degrees, meaning my x will now know what? My x will be 90 minus 60 degrees, which is 30 degrees. Check, because this side is 90 degrees. So that the bearing of z from x is 90 plus 90 plus 30. And then 90 plus 90 plus 30. 90 plus 90 is 180. 180 plus 30 is 210 degrees. Thank you very much. Please like, share, and follow for more videos on bearing and distances.